of our weekly live series, and I welcome all of you to this session number 16. So let us first take some questions that have been asked on the Google form, and then we will take questions from our live audience. Okay, so let me just share the screen and let's see what has been asked. So till this 159 we have taken it in the last session. So I'll start from this. So Komal from Sangli, she is a student. She is asking, I have to design a shelter using ETABS as a mini project. Can you guide how to initiate and follow the steps for it? So steps will be simple, just like in any other, just for any project, the steps that you follow, same steps you will have to follow over here also. So you can start with, you will need to start with modeling. After modeling, you will have to do the load calculation and load application. After that, you will have to, once you apply the loads, then you will have to go for analysis, and after analysis then you can go for member design. So I mean the process or the sequence to be followed remains the same. That is not going to change. So I mean, if you have any specific doubt related to this, you can ask. Otherwise, the basic process is the same for any project that we follow. So that will be the process for initiation. Okay, just give me a minute. Yeah, so modeling and followed by, where is it? So modeling and then followed by load application, load combinations also you'll have to define, followed by analysis, and then your member design. So this is the, I mean, these are the process that you need to follow. I think there is some issue with screen sharing. So if you want to initiate any project, that is what you need to do. Now, because it's a shed-like project, you will have to define your, or you will have to finalize your geometry first, then see what are the applicable loads. So applicable loads in this case will be dead loads, roof live load, and wind load. Then you choose your, then you do the analysis, and finally member design. Okay. So if you have any specific question, uh, it will be better. Then CH Trilok Raju from Vijayawada, Andhra Pradesh. He is a working professional, and he has asked couple of questions related to beam deflection check. So let me just take those questions. Yes, I hope this is visible. So RCC building, how to check deflection in software? He is asking, what are the limits for deflection? As per this clause, uh, this should not exceed this, whichever is less. If the beam passes the design while designing in software, can the deflection of beam be neglected? The software ETABS or STAD also automatically checks and designs. So see, software like ETABS and STAD, they usually don't, they will check the deflection and they can give you a pass fail message, but then it is your duty or your job as a structural engineer. Is the video still stuck or is it okay now? Okay, so it is your job as a civil engineer or structural engineer to finally ensure that this deflection check is, that the deflection check is passing. Okay, so software, for example, in ETABS, uh, as far as I remember, ETABS will not directly give you a deflection pass fail check. STAT is able to give you a pass fail check if you apply that, those DJ1, DJ2, and deflection parameters. But even after that, it's your responsibility to ensure that deflection is within the codal limits. Okay, so limits for deflection you have already mentioned, and those are the limits as per the code. His next question is, I have designed an RCC building and the deflection is beam is very high for a size of, for a beam size of 450 and 500 mm. He is saying that his beam deflection is very high, span is 9 meters, and deflection is 52 mm. So if you do permissible 9,000 upon 350, you will see that this value, permissible deflection, comes out to 25.71 mm, but you will have to limit it to 20 mm. So when I checked in service beam, see, beam is passing in ultimate checks. That means beam is passing for limit state of collapse. But in this case that you are doing, your beam is not satisfying the limit state of serviceability deflection. So although the beam is passing in limit state of collapse, because it is not passing in deflection, it is still, it will be called as failing in deflection. So serviceability limit state is not yet satisfied. So you will have to satisfy it. You cannot neglect the deflection. Okay. So it has to be ensured that deflection is within the limits. Actually, the deflection should be checked together with the modification factor. See, modification factor approach is a different approach. Modification factor is a approach, is an approach when you are sort of just satisfying the L upon D ratio, when you are satisfying the L upon D ratio, and because you have satisfied the L upon D ratio, you assume that deflection will be satisfied. So in the code, there are two methodologies or two approaches. One is that you find out the actual deflection and then ensure or then check it with respect to L upon 350 or L upon 300, L upon 250, whichever is applicable. That is one way. Second way is you provide the L by D ratio of your beam in such a manner that it satisfies the codal ratios. For example, for continuous beam, it is 27, I think. For simply supported beam, it is 20, I guess. So you satisfy these ratios, L by D ratios, and if your L by D ratios are satisfied, that means the depth that you have provided is as per this L by D ratio, then you can assume the deflection check is satisfied. In that approach, the concept of modification factor comes. Okay, so concept of modification factor comes over there. But in this approach, where you are, let's say, calculating analytically the deflection value, there you have to verify or cross check that deflection value against L by 350 or L upon 250, whichever is applicable. Over there, there is no concept of modification factor. Clear? So short answer is that modification factor approach cannot be used if you are, if you have calculated the deflection analytically and then comparing it with L by 350 or L by 250 limit. Okay. Yeah. So I hope that is clear. All right. Then next question is uh, by Mr. Dinesh. He is a working professional and he is asking He is modeling a 3 basement plus G plus 10 floor in STAD. I hope the question is visible. So he is modeling a 3 basement plus G plus 10 floor. So let's say this is your G plus 10, and then he has got basement, 3 basements. Let's say this is raft, and there are 3 basements over here, whatever. Retaining wall height is 8.5 meters. How to model you can make. So for basement walls you can model it using the plate elements in STAD. So you model it using plate elements in STAD, and then you do the required meshing. His next question is how to model and apply loads. So load application, again you will have to first calculate the loads due to your soil fill, and if there is any surcharge or if there is any water table. For that you will have to calculate and then apply the loads, triangular pressure distribution. So there is an option in STAD of hydrostatic loads. You will have to use that approach to apply this load. Okay, right? In our course on tall buildings, we have discussed this issue in great detail. But I think you can do it. You can do the calculation. Refer to any book, and you will be able to do this calculation. And then this load you need to apply. So you can use that hydrostatic option available in STAD to apply this load to achieve propped cantilever retaining wall. See whether it is propped or whether it will depend on the connectivity. So you model the actual configuration that you are getting, and from there, depending on the structural connectivity and the actual configuration, you will get the desired result. Okay, desired result means you will get the bending moment shear force in this wall in such a manner as per the structural connectivity and configuration. Okay. His next question is Mr. Dinesh is asking, in one of my projects, footing layout overlaps with retaining wall layout. In this case, how to do pressure checks? So his question is that, for example, I'm showing you a plan view. This is my retaining wall, and suppose for this retaining wall, this is, let's say, a strap footing that you have given, and then there is a column. So the column footing is like this, and this is the plan view, and you can see that this is overlapping. Okay, so his question is, in this case, how to do the pressure checks. So see, manually, if you want to do it manually, you can. It will be slightly difficult because if it's overlapping, what you need to do is that you will have to either combine it like this. So finally your footing will be something like this, where you have provided a combined footing. So you will then need to do pressure calculations. This manually doing it may be slightly complicated because from retaining wall there is some pressure distribution due to the moments acting on this retaining wall lateral soil fill, and then there is, due to this footing, there will be some pressure distribution of that. So once you combine it, then you also have to consider the differential settlement because of combining them together. So that concept will also come into picture. Okay, there will be concept that because of the load eccentricities, again you will have to calculate the pressure. So manually doing this may be slightly complicated. So in such cases, maybe you can take help of safe software or you can take help of stat foundation to see what sort of pressure distribution, and because of that pressure distribution, what are the moments, bending moments, etc., that you are getting in the footing. So in such a case, I would recommend you to better to go ahead with modeling this scenario in a actual software. Manual calculations will be slightly difficult in this case, so that will be my suggestion to you. Okay. Next question is from engineer Tosh Agrawal. He is practicing engineer in Raipur. So he is asking, which kind of floor system will provide effective lateral restraint to beam like grating or deck slab or checkered plate or corrugated sheets? See, important concept to be understood over here is that, let's say this is your steel beam in sectional view. Now, whichever flooring option, suppose you are going ahead with a grating. So gratings are usually just kept like this. Grating is usually just kept on the top of beam with not a very proper connectivity. Okay, generally you will just apply some uh, welding, or in most of the cases they'll just put grating like that only. Or if you are putting checkered plates, there are chances that they will have some cleat arrangement done over here, and on that cleat arrangement you will provide your checkered plate. If you are doing a deck slab arrangement, in deck slab arrangement maybe it will be more, although the corrugations will not be like this, but just for clarity, just for imagination purpose, I am drawing like this right now. And imagine that this deck slab is spanning perpendicular to the screen, and then it is going to be filled with concrete. So here you may have to provide some shear studs, etc. So what I'm trying to tell you, that whether it's a checkered plate option or a deck slab or grating, usually you need to understand this thing, that how are these things getting connected with the steel beam. Okay, so the connectivity needs to be understood, because most of the cases your flooring system may be such that it is just being kept on the top of the beam. So you need to first understand how the connectivity is being done. Depending on the connectivity, the general principle to be understood is that whether the connection between, let's say, flooring and your beam, whether it is able to take 2.5% of load in compression flange of the beam. So if that much load is capably and ably transferred, then you can say that that particular floor system is providing effective lateral restraint, not otherwise. So out of all these different options, I would say that the deck slab plus concrete arrangement is the best suited arrangement to consider effective lateral restraint, because the deck slab is connected to the steel beams through shear studs, and then you have got this deck sheet connected properly, and then you put concrete topping on it. So the connections are also quite, uh, I would say the connections are also enough to take this 2.5% of load in the compression flange as compression. And even then, this deck slab system with concrete is strong enough to take that 2.5% of the load. Okay. So short answer is, out of these three, you first need to see what type of connectivity is provided, and then you need to accordingly decide. But deck slab with RCC topping can always be assumed to provide effective lateral restraint. All right. Okay, so these were the questions asked on the Google form and on the email. Now let us take a few questions from the live audience on YouTube. So engineer Neeraj Kumar is asking how the lattice tower, how wind in the lattice tower, how wind loads to be applied. So you can use two concepts. In IS 875 Part 3, there are detailed tables given. So lattice tower wind loads, two concepts need to be understood. One is the solidity ratio concept, and one is the shielding factor concept of shielding. So for both these things in the code, there is enough information available, and there is sufficient literature also available. You can refer to the explanatory Wind 06 document prepared by Dr. Abhay Gupta sir and his team under GSDMA. So this document, you can get it on the internet also, explanatory examples for wind code. So you can go through this and you will understand the basics of this calculation. The important concepts, as I just told you, will be the important concepts to remember will be solidity ratio and shielding. Okay. Cars World is asking for a structural engineer job as a fresher. What should we prepare for the interview? So I would say the basics of maybe RCC and steel design as a fresher. So the basics of IS 456 and IS 800. Then a few things about concrete as a material, different grades of concrete. I am assuming that you are preparing for a structural engineer interview. Okay. Yeah. So concrete and a few things about the material grades of concrete, grades of steel, etc. As I told you, basics of RCC and steel design. And at B level, as a fresher, I would say that is enough. But some people, I don't know, they might ask you some basics of wind and earthquake also, wind and EQ calculation. Although at B level, you may not be expected to know it, but it might be asked. But I would say just the basics are enough, and a few basics about structural analysis and strength of materials, including some BMD plus SFD plus deflection, behavior understanding. Okay. So I think that much is enough as a fresher for your job interview, I would say. Mr. Sanjeet Kumar is saying मुझे पी डेल्टा एनालिसिस में इशू आ रहा है. नहीं, you have to tell me what is the issue you are getting. Ranjit Kumar is saying, I have required a high-rise building course. We have conducted a multi-story high-rise building design course. Maybe you can refer to that. It will help you to understand the different design and detailing concepts related to high-rise buildings. Mr. Neeraj Kumar is saying, my question, I just answered 5 minutes ago. I just answered. So I said that you need to refer to, or you can refer to this explanatory document available on Wind Code, or you can just write a message on WhatsApp to me. I'll just share that document. The important concepts for lattice tower type of structures in wind load application to be understood is concept of solidity ratio and concept of shielding. Okay. Yeah. Then gust factor, explain it. You should ask specific doubts. What is your doubt in gust factor? See, try and ask specific questions. Explaining a concept will require me 2-3 hours, so that might not be possible in live session. It is better to ask specific questions related to it. Mr. Tejas Kriya is asking how wind tunnel analyze how wind tunnel analysis affects our design. So see, there is a codal requirement that above a certain height, if your dynamic properties of wind and the vibration characteristics of your structure, if they are going to dominate, then it is better to get a proper sense of how the wind load is going to act on the structure, and for that we usually carry out the wind tunnel testing. So when your building height is above a certain height, or there is a structural complexity, so your building may not be very tall, but it might have some complexity of form and shape, for which your tables or for which your coefficients may not be readily available with you. In such cases, your code requires you to undergo or to take wind tunnel testing. Okay, so you will have to make your actual model and do the wind tunnel testing for it. So then whatever the outputs you get, those outputs or those wind outputs, then you will apply to your structure. So how wind tunnel will analyze how wind tunnel analysis affects your design, because the wind tunnel calculation will not be done as per the coefficient based approach, but as per the outputs that you get from wind tunnel. Okay. uh, Hamad Sarguro, bridges or building, what to choose if I have the opportunity between the two? No, it's not. I mean, it's not either or. You decide what is your interest. You decide. Uh, you decide the market dynamics. That means what is the demand supply uh, in your part wherever you are living, about whether to go for infrastructure and bridges or building. So usually if you see, structural engineers are more inclined towards buildings. So there is always lack of structural engineers in bridges. So maybe bridges have more opportunity that way. But then the bridge projects are also not that great. Not, I mean, not so many in number. So you will often find buildings to be the more commonly built structure as compared to bridges. So that is also another thing that you need to understand. So it's all about the demand supply, and it's about your interest uh, in a particular topic. Then Mr. Mohammad Farhan is asking, the deflection for the ridge rafter depends on slope. As I noticed, some PEB consider overall span length for LZ factor. Some consider it as half due to rigid haunch connection. Which approach? See, generally LZ they are trying to reduce, because they say that in your, let's say your, this is your PEB structure. So what their logic is that it will depend on sort of your bending moment diagram that you are getting. Okay. So if your bending moment diagram is like this, what's happening, that this portion, the top flange is under compression. For this portion, bottom flange is under sorry. For this portion, the bottom flange is under compression. For this portion of your rafter, the top flange is under compression. Again, for this portion, the bottom flange where your hugging moments are, that is under compression. So while taking the effective length for bending for lateral torsional buckling, people what they do is that they will try to take a smaller length, because they say that this is the length over which lateral torsional buckling is going to happen, uh, because of the reverse curvature of bending. All right. So therefore, because we are not taking a moment coefficient factor as C1, which is given in Indian codes. In American code, they call it as CB, moment magnification, moment, no, not moment, what do they call it? Yeah, I think moment magnification factor, which helps you to increase the critical buckling moment MCR in the Indian standard or the critical buckling moment in the AISC code also. So it basically helps you to increase the moment carrying capacity of your beam, this C1 factor or CV factor. So many structural engineers, they say that because they are not using those C1 or CV factors, they'll reduce the effective length. So that's why some people will take half the effective length, some people take full the effective full length of this rafter as LZ. Some people say that take half because your bending moment diagram is such that the uh, curvature is reverse curvature, and therefore the LTB effective length can be reduced. So they do it this way. So there is not a, it's all as per the understanding of structural engineer, the approach that they take. Okay. So you could, in fact, what you could do is you could take the full LZ and you could apply the C1 factors or CB factor as per the American standard. So by taking that, you will be able to increase the moment carrying capacity. So you take the full LZ as the full rafter length, but then use the modification factor C1 and C1 as per Indian standard, CB as per the American standard. Mr. Neeraj Kumar is saying he was asking about the lattice truss, a lattice tower, how to calculate Ka. So Ka, you are saying the area averaging factor. So area averaging factor, it will depend on the tributary area. So again, you will have to refer. You will have to calculate the total tributary area and then find out the Ka. And you apply the loads on your members, exposed members. Okay, Mr. Magaj is asking for 3 meter raft foundation, how the casting work is done. How 3 meter deep raft is cast? Is there any special detail as it is mass concreting? So, are there any vertical strips? Stirrups or strips? What are you saying? Is there any codal provision where uplift due to lateral load is? Acha, nahi. So, regarding raft thickness for deeper rafts, let's say you have a 3 meter raft and you have to do its construction. So it will also depend on the season in which you are doing. It will depend on in how many cast you are going to do. Suppose the volume is so much that you are only able to cast, let's say 1.5 meters, okay, out of the total 3, suppose. So you did not opt for continuous casting, you were able to do 1.5. In that case, you will have to provide dowels like this. You'll have to cast half of these dowel bars inside the old concrete, and then you can have a grid of these dowel bars provided, and then when the new concrete is to be cast, you can just roughen up the surface and put this new concrete. So this will help you to not have a cold joint and have proper joint between the old and the new. This can be one of the ways if you are going to do not a single cast but in multiple casting. uh, if temperature is a problem, and if it's a mass concrete, suppose you are doing it in summers, maybe you will have to use pre-cooled aggregates, or maybe sometimes people use your water at a slightly lower temperature, uh, depending on the depending on the season in which you are doing the casting and the ambient temperature of that location. Okay. Yeah. Yeah. Pore strip and shrinkage strip, vertical direction, generally no. It will only depend on how much casting, how much depth you are able to do. So wherever you are, if you are not able to do continuous casting over the full depth, wherever you are stopping, you will need to ensure proper bonding between the old concrete and new concrete. So the ways to do it is either you use some double bar arrangement like this, or you use some nito bond or some bonding material, or you sometimes they spread a layer of aggregate. So that aggregate is partly inside the old concrete and partly exposed. Then when new concrete comes, it forms a proper bond. So all these strategies are available. Okay. Mr. Magaj is asking, is there any codal provision where uplift due to lateral loads is allowed like 5% or 10%? I remember seeing it in one of the IRC standards where they had not allowed more than 50% of the footing to exceed, where they had not allowed more than 50% of the footing area to undergo uplift. I remember seeing that in one of the IRC standards. Uh, I think somewhere else also I saw, but I'm unable to recall the code in which this uplift area under uplift is given. Okay. Generally, 50% is the upper limit, provided that the remaining area which is still in contact with with soil, there the bearing pressure should remain within the limits, permissible limits. So, as I just said, in one of the IRC, I remember seeing it as 50% of the contact area of the footing area to have left contact. That is the upper limit, but I'm not able to recall that code number where I saw that. Mr. Ahmad is continuing with his question. He had asked about whether bridges or buildings, which is the better option. So he's saying technical inclination is towards bridges, but is it true that it's more easier to start on our own in buildings? Yeah, because see, buildings will always be uh, made by either private agencies also. In case of bridges, the limitation is that the executing agency will be some contractor, but the governing agency in bridges will always be some government department. So there is this limitation that you often find in infrastructural projects, that finally it has to come under some government department. So it has its own inertia working in a government department. There will always be lot of norms and lot of rules you need to abide to. So there are those factors, of course, that it is slightly more difficult to start on your own as a bridge consultant as compared to a building structural engineer for buildings. Yes, I do agree. Okay. Mr. Sanjeet Kumar is asking where the course purchase. You can contact us on WhatsApp. I'll just put the number on in the comments, so you can contact us over there, and we'll provide you the details. Okay. Then Mr. Arbaz Kazi is asking, in the US, the typical commercial construction is central core, which takes all the lateral loads, whereas surrounding columns are steel structure with composite deck. Then how the detailing is done of steel beam and concrete core so that proper diaphragm action takes place. See, the steel beams in plan, if you are providing, those are usually stiff enough and strong enough, so the steel beam itself will act as the collector and distributor element. So even though you are going to provide deck slab with concrete topping, let's say, but even without that also, because of the uh, steel beam framework that is provided, properly connected to concrete core and then connected to a peripheral system, the beams themselves are quite sufficient to transfer the lateral loads from slab levels to vertical elements. Okay. Yes. Okay. Anything else? Mr. Arbas Kazi is saying, but the steel structure are mostly shear connection means gravity system. In that case, you will have to ensure or you will have to provide another system. So that's what I was saying. Maybe in form of bracings, plan bracings. So you may have to introduce plan bracings, which will help you to transfer the load from your core walls to the other vertical system. That can be one of the options. Or you will have to introduce bracings in elevation, or you need to introduce belt trusses and outriggers. All those types of options you need to look into. All right. So there will be this gravity system which is taking your floor gravity loads, and then you will have to ensure that another system is introduced to take the lateral loads and transfer it from core walls to the peripheral system or vice versa, whatever. Mr. Neeraj Kumar is saying any literature for lattice tower design. See, for lattice tower, as I just said, this wind explanatory W06 prepared by Abhay Gupta sir and his team uh, is very helpful. This you just type explanatory examples on IS 875. Chances are that you will get this document. If not, you just send me a message. I'll send you that document on WhatsApp. This is the number. Okay. Okay. Mr. Kikro Kiki is asking, can you please share about the precast building construction in India and its future ahead? See, I don't have much of practical work experience in precast, although the basics are somewhat understood by me, but practical experience of doing projects I don't have. But of course, the future in any industry where labor is going to be issue. Over there, this precast construction, or for that matter, in steel structures, pre-engineered construction these days, pre-engineered and prefabricated construction, all these will gather a lot of popularity because of issues related to site labor issues, site issues, environmental issues. So, due to all these, every technology like precast or pre-engineered, prefabricated steel, all these will of course get a lot of popularity. Okay, so what is the scope? I would say in coming years, more and more things will get being constructed as precast systems or pre-engineered, prefabricated systems. But I don't have working knowledge of precast systems as of now. Mr. Arbas Kazi is saying in our design firm, we don't design beams for torsion. We keep the modifiers as 0.001, 0.01 for torsion. I hope you are doing it for the peripheral beams only. So when checking long-term deflection, we release the slab edges. No, so why are you doing both? I mean, if you are releasing the slab edges, why are you applying torsional modifier? You do one of them. That means either you release the slab edge or you release the torsion modifier. No need to do both, and only release the slab edges on the periphery where there is a discontinuous edge. Also for beams, only apply torsional modifiers on the peripheral beams, because at the internal beams or at the continuous slab edges, there will always be this compatibility due to continuity, and over there you cannot release the slab edge or you cannot apply modifiers in torsion to the beam. Okay. Checking for long-term deflection in safe, I would say, is not related to whether or not you are applied provided modifiers in torsion. And if you are releasing the slab edges, I don't know why you are releasing the slab edges. At least for the internal continuous edges, you should not release the slab edges. See, I am saying that suppose you have this in plan view, this is your beam. Let's say this is your column. I am drawing the plan. This is your beam, column, and beam, beam, and maybe another beam, something like this. So what I'm trying to tell you that over here the slab is discontinuous. So let's say on these peripheral beams you provide torsion modifier, okay? Because you are relying on the compatibility of slab and the beam. That means if moment is not being taken by the slab beam junction, that moment will get transferred to the slab midspan and it will be okay. But at this edge, where the slab is continuous or the slab is continuous over the beam, applying torsion modifiers to the beam is not correct, not appropriate. That is what I'm trying to tell you. And then if you are checking long-term deflection, so let's say you have applied the torsion modifiers, then you don't need to apply the slab edge releases. No need to do both. Either you apply torsion modifiers to peripheral beams or you apply slab edges, slab edge release to these discontinuous edges. Don't do both. And if you are doing any one of it, let's say you have not applied torsion modifiers, you have released the slab edges on the periphery. For long term deflection, you don't need to do anything further. Okay. So just check in this condition the long term deflection. All right. What else? Any other question we have? Okay, so we have taken all the questions on the Google form and we have also taken all the questions on email. We have also taken the questions on live comments. So, is there anything else? Okay, then. So, I think that's all for this episode. There are no further questions. So, that's all then. Thank you. And we'll see you next week. Same time, 7:30. This Google form that has been shared, you can use the form to keep putting your queries, and every week when we meet in this live session we'll take those queries. Okay, so I'm just putting the link for Google form once again in the comments. You can use this link to keep inputting your queries, questions, and every week when we meet we will take them up. Okay, so that's all. Thank you, and thank you for joining us. Have a good weekend. Bye bye and take care.